Hello people, hope you have a wonderful day. Welcome to Tech and Machines. Let's start with my Spark journey. On day 1, I would like to present a short video on how Coalesce versus repartition works. Before we go into the formal definitions of Coalesce and repartition, let's start with an example. Let's say somebody has given you a rearranging task to arrange bookshelves. Now you might have two options. One, you might reduce the shelves by merging the existing shelves, or you might create new shelves and rearrange books extensively. So these two rearranging options are nothing but Coalesce and repartition. It's just an analogy to define how Coalesce and repartition works in an ideal world. Let's go into each of the definitions we have. Now, Coalesce being an efficient one, which helps to reduce the number of partitions in a data frame, it tries to minimize the data movement by merging the existing partitions and also avoids any shuffle operation. But it has its own downside as well. It can cause data skewness or uneven data partition. Whereas repartition, on the other hand, can shuffle the data and create new set of partitions. It does involve full shuffle operation, but can evenly distribute data and help in parallelism. Whereas it is more resource intensive comparative to Coalesce. Let's dive into an example. I'm using Jupyter Notebook. I have already created a Spark session by assuming that you are aware about the Spark session. In another video, I can cover what Spark session and Spark context means. But here, I have already created a Spark session and a Spark context where we are creating a data frame using a data of type name and age. Now, before we coalesce or repartition this data, we will print the number of partitions this data frame already has. We will use getNumPartitions function on RDD to describe how many partitions this data frame has. As you can see, this data frame has 8 partitions. Now let's create a coalesced data frame on the current data frame by calling Coalesce function with the specified number of partitions as 2. Now when we print the number of partitions on this particular data frame, you will find that the partitions have reduced to 2. As you can see, the partitions have reduced to 2. Now let's use the same and create a repartition data frame, this time by using by using a repartition data frame and giving the number of partitions more. Now once we print in a similar way the repartition data frame, we'll find that's basically have 4 partitions which we just edited. So as you can see, the main difference again in Coalesce, it's reducing the number of partitions, and in repartition it is ending up increasing the number of partitions or might reduce as well. But in both, the key difference is the data distribution, how they handle the data distribution. Hope this gives you a better vision of how Coalesce and partition works. This is a short summary. Thank you and have a nice day.